One of the famous equations in physics is that E equals mc square. This equation is presented through the special theory of relativity presented by Mr. Albert Einstein in 1905. This is a wonderful relationship between energy and mass. Who would have thought that mass is made of energy, and that mass can be converted into energy and energy into mass? So like everything in this world, we all have energy inside our bodies. How much can this energy be? Shall we approximately calculate this? We can calculate this using the equation E equals to mc square. E stands for relativistic energy, m is relativistic mass, c is the speed of light. What is relativistic energy? Relativistic energy is the total energy possessed by a mass when it moves. Relativistic mass is the total mass of a mass when it is in motion. The amount of mass when a mass is in motion is always greater than the amount of mass when the mass is at rest. This is the relationship between relativistic mass, rest mass, and moving velocity. Relativistic mass equals rest mass divided by the square root of 1 minus the square of the velocity divided by the square of the speed of light. Looking at this equation, we can see that when a certain mass's moving velocity is 0, its relativistic mass is equal to the rest mass, and when the velocity increases, the relativistic mass increases. This mass change is not visible for the normal motions that we see in everyday life. The reason is that the velocities of motion in the normal world are very small compared to the speed of light. This mass change can be seen when an object moves at a significant speed compared to the speed of light. What happens if an object tries to move at the same speed as light? There are different opinions about this, but according to this equation, when the velocity of an object increases, its mass increases. As this velocity approaches the speed of light, the mass approaches infinity. So according to this equation, it is practically impossible to reach the speed of light. There is something else that happens when an object's velocity increases. That is the decrease in the passage of time. This is called time dilation. Time passes slower for a moving object than for a stationary object. When an object travels at a significant speed compared to the speed of light, we can see this difference in the passage of time. And another thing that happens when traveling at high speed is length contraction. That means a reduction in length. We will talk more about this in an upcoming video. Okay, let's look at substituting some data into this equation. For example, let's take a man weighing 65 kilograms. Substituting this data into the E is equal to the mc square equation. The total energy obtained is 585 by 10 to the power of 16 joules. This amount of energy is approximately 1.377 billion tons of TNT. You look at it another way, it is almost 390,000 times the energy released by the atomic bomb that was dropped on Hiroshima. So if there is so much energy inside the mass, can't we find a solution to the energy problem? But converting this mass into energy is not so easy. This is what happens in a nuclear power plant. That means converting mass into energy. What happens here is the fission of the nucleus of an unstable isotope of atoms such as uranium-plutonium by a nuclear reaction. In this nuclear reaction, part of the mass of atoms is converted into energy. This is what happens in an atomic bomb. More details about it will be mentioned in the upcoming video about the story of the atomic bomb. Okay, let's look back at the E equals mc square equation. How to derive this equation? A hypothetical experiment is used for this. That is Einstein's box. Okay, let's suppose a box of mass capital M is inside a closed system. There is a light source on one wall of that box. Consider a photon of light emitting towards the other wall on the opposite side of this light source. A photon has momentum, but a photon doesn't have a mass. So let's assume that the momentum of this photon is capital P. According to the momentum conservation law, this box gets a momentum in the direction opposite to the direction of the photon. Let us assume that the velocity of the box is capital V at this point. Let delta t be the time it takes for the photon to travel from the wall where the light source is to the other wall. When the photon reaches the wall on the other side of the box, imagine the box has moved a distance of delta x from its starting point in the direction opposite to where the photon traveled. According to the momentum conservation law, the momentum of the box is equal to the momentum of the photon. The equation P equals mv cannot be used to find the momentum of a photon. The momentum of a photon is given by the equation P equals E, where C. E is the energy of the photon. C is the speed of light. Let's talk more about the photon in an upcoming video. The momentum of the box can be taken as capital MV. Since the box travels a distance of delta x in delta t time, this can be expressed as m times delta x divided by delta t. So according to the law of momentum conservation, since these two momentums are equal, capital M times delta x divided by delta t can be written as capital E divided by c. If we consider the motion of the photon, it travels a distance L dash within a time delta t. Since the photon has a velocity c, we can write it as c equals L dash divided by delta t. This can be substituted into the previous equation and written as capital M delta x equals E over c squared times L dash. If we consider the center of mass of this system, the center of mass remains unchanged despite the motion. There is always mass associated with energy and energy associated with mass. Let the energy of the photon be capital E and the mass associated with that energy be m. So, by considering the center of mass for the first case and the second case, we can get an answer like this. M times L dash equals M times delta x. By replacing capital M times delta x equals capital E over c squared times L dash into the equation mL dash equals m delta x, we can get the equation E equals mc squared. Stay tuned for more scientific information like this. Please comment your thoughts below.